All right, ladies and gentlemen, class recording has started. So, up on the board is our calendar from the past week, just to make sure we review where we've been. First thing we did on the first day of this unit dealt with the first section of chapter 6 and introduced you to terms like chemical reaction, reactants, products, things like that, exothermic, endothermic. Those are terms, we already started to use some of them. We'll use more of them as this unit goes on. On Thursday of last week, we talked about the different types of chemical reactions and how they fall into patterns when we start looking at what the reactants are and what the products are and how this reaction is similar to that reaction, etc., etc. Then on Friday, we talked about chemical equations and balancing chemical equations. And we are going to do a little bit more of that today, a lot more of that today. That is our plan for today. So first, before we get into the problem from the book, what is a chemical equation? What does a chemical equation do for us? Nora, you want to take it, or you look like you were thinking about it? So go ahead. Shows the reactants and the products. What are the reactants, Noor? What are our definition of the reactants?
They're the elements that they're chemically bonded.
Okay, so they're the things that are present when in the chemical reaction, before the chemical reaction occurs, and then the products are after. Okay, so we said that one important factor that has to be true when we're looking at a chemical equation is it has to be balanced. What does it mean to say that a chemical equation is balanced? Okay, go ahead.
The same amount of the substance.
The same.
A ratio
The same amount of what substances?
of the reactants.
I want a different word in there. What are we looking to count up when we're looking at balancing equations? Jay. Not compounds. Atoms. We're looking to count up the number of atoms. That we have to have the same number of atoms in the reactants as we do in the products. Okay? What is that based on? What concept is that based on? The idea of balancing an equation is based on what concept? John? Conservation of mass. Or conservation of matter, same idea. That you cannot create or destroy matter. Whatever's there at the beginning has to be there at the end. It might be in a different form, but it's got to be there. Okay? All right, good there? So to start off today, I would like you to look in your book on page 215, and we are going to start off looking at number 22. I don't have an electronic copy of the book, so I can't show it to you up here on the board. But what I want you to do is I want you to read number 22. And when you are done reading, go ahead and close your book real quick, just so I know that you're done, and then we'll discuss together as a group. Go. Okay, looks like most of us have gotten to that point. So, we talked about the idea, Noor, you told us that a chemical equation shows us reactants and products, right? Okay. What's there beginning, what's there at the end. So, first thing that it tells you about this reaction, what does it tell you about this reaction in your reading? It describes the reaction as what? Noor, go ahead. You can look it up if you want to. Or if somebody else wants to. What does it tell us about this reaction to begin with? Well, it doesn't tell us that it's balanced just yet. It actually wants us to balance it, right? What does it tell us about it? Captain, go ahead. It's a... okay. It says that we heat it, right? All right. So generally, if we have to heat it, that means it's probably going to be an endothermic reaction because we're putting heat into it. But more importantly, what does it tell us about what kind of a reaction it is? Someone else can jump in if they would like. So, doing good. It is a decomposition reaction. Julian, as a basic description of a decomposition reaction, what are we going to look for to happen? Okay, compound produces two elements, or more generally, something big produces things that are smaller, right? So, as a general rule, what are we going to see about the number of products versus the number of reactants? As a general rule, what are we going to see about the number of products versus the number of reactants? More products or more reactants in a decomposition reaction? More products, right? We're going to break things up. So, it tells us that we start with what material? Mercury oxide. And it gives you the formula for mercury oxide to look like this, right? And then it says that it produces two products in this reaction, right? What does it produce? Mercury and oxygen. So, a couple of things. First, how do we separate reactants from products in a chemical equation? How do we separate the reactants from the products in a chemical equation? How do we tell where the reactants are and where the products are? There's an arrow in between them, right? So, reactants start off and give us products, okay? Now, in this equation, there are two products. How do we separate the two products? Plus sign, okay? Now, something that's a little complex, and I wouldn't expect you to get this right off the bat, but there are some things that we need to know about certain elements in order to properly represent what they end up like out there in nature. So it tells you that it produces oxygen gas in the reaction, okay? Oxygen is one of our diatomic molecules, which means how does oxygen come out there in the real world?
With two.
With two of them, and those two are what, Christine? How would we describe those two? Are they two atoms just out there?
No, they're like together.
They are, what do we call it when they're together? They are bonded, right? So, Christine, how do we represent that there are two oxygen atoms bonded together? Anyone else? Rachel. Subscript, right? The subscripts represent atoms that are bonded together, right? So in this case here, oxygen being a diatomic molecule, and it's one of the products of this reaction, this is how we represent that, okay? Real quick, this will come in handy a little bit later on. Oh, where did I put it? There it is. All right, here's your periodic table. There are 7 diatomic elements on the periodic table. One of them is hydrogen. It's all the way over here up at the top. The other 6 are all nonmetals, because we said that a diatomic molecule is held together by covalent bonds. So you need to have non-metal things, right? So these 7, hydrogen, and then nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Those are your 7 diatomic elements. So in this case, when we produce one of them in a reaction, or if one of them shows up as a reactant, we can't just write it as a single atom. We have to write it as a diatomic molecule. Okay? Good there with that? Okay. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Those are our diatomic molecules, or our diatomic elements. Okay. Continuing on with what we were doing. So now, we have written the equation to represent what we started with reactants-wise and what we ended up with products-wise. But we have to make sure that this reaction is, or this equation is balanced so that we do not violate conservation of mass. You don't have to do it this way, but I will go through it. If you can see it, this one's pretty easy to see, and that's okay. But just to go through the process, right? We start off, and write the symbols of the elements that show up in our equation underneath the arrow. Then we take what we call an atom inventory, right? Count the number of atoms of each kind in the reactants and the products. So in the reactants of this reaction, there is 1 mercury and 1 oxygen. And then in the products of this reaction, there is 1 mercury and then there are 2 oxygens. So as this equation is written, is it balanced? It is not. We need to have the same number on both sides. So we need another oxygen in the reactants. So we come over here and we do this, right? No. Right? So, Christine, getting it back to what we were talking about before, right? This represents what? If we write that formula this way.
The reactant.
Yeah. What is in the reactants?
1 mercury and 1 mercury oxide.
Mercury oxide, and that is what
1
we
mercury and 1 oxide.
1 mercury, 1 oxygen, and they are what? Bonded together. If I do this, what is that representing?
That's not the same thing.
Not the same thing, right? What is this? Just what we did before, right? What is this representing?
So 2 oxygen.
2 oxygens
1 mercury.
and they're all
Bonded together.
bonded together. That's not what we can do, right? Like you said, Christine, that's not the same thing, right? So, we don't do it that way, right? We have to add the coefficient out in front. What does the coefficient do for us? What does the coefficient do, Christine?
It like adds more of that element.
It adds more of that, let's not go element,
Atom.
more of that,
Bond.
yeah, what do we call it when these 2 atoms are bonded together? It is a
Molecule.
compound or a molecule, right? So, in this case here, it's still 1 hydrogen and 1 oxygen that are bonded together, right? But now there are 2 of them. So that changes our oxygen from 1 to 2, but it also changes the mercury from 1 to 2. Now we're balanced oxygen-wise, but not mercury-wise, right? So we got to do something this. We got to do this, right? No. Okay? If I throw that subscript there, what is that representing? Andrew, go ahead.
8, 2 molecule atoms,
That are what?
diatomic,
Yeah, it's meaning that it would be 2 mercury atoms that are what?
connected.
Connected, bonded together, right? And that's not what happens, right? So here we throw the coefficient out in front like that, and that changes mercury from 1 to 2, right? But that's representing what? If we throw the coefficient out in front, that's representing what?
What was the question?
If I throw the coefficient out in front of this formula, that's representing what? It's 2 what? Not 2 molecules, it's 2.
Atom.
This is a single atom, right? This is 2 separate atoms, okay? Not bonded together, separate from each other. Good there? All right, next. Again, page 215, but this time, number 23. Read it. Determine what are your reactants, what are your products, and come up with the equation to represent that reaction. You can talk to the person next to you if you need a little bit of guidance. So what are your reactants? What are your products? So, what are the reactants for this reaction? It says what? Go ahead.
CH4.
CH4, and that's called what?
Um,
What does it tell you that's called in the problem?
methane.
Methane, right? And what else?
Oxygen.
Okay, and how do we write oxygen?
O2.
O2.
To produce water.
Hold on. Just reactants, right? Okay. So these are our two reactants, right? Okay. Noor, what do we have to do here? Because these are two separate reactants, we have to put what in between them? A plus sign, right? So these are separated because these are two separate reactants, right? These two things come together to form two products, right? What are the two products that tells you that this reaction
Water and carbon dioxide.
Water and carbon dioxide.
H2O and CO2.
Good there? First, before we go any further, what kind of a reaction is this? What kind of a reaction is this? Nope, not a double replacement reaction. Nope.
Oh, combustion.
This is a combustion reaction. It is a combustion reaction because here, O2 shows up in the reactants. That makes it a combustion reaction. Okay? Now, this is a specific type of combustion reaction that we talked about on Friday. This is the combustion of a hydrocarbon. This product here, right? This is carbon and hydrogen. We said that when hydrocarbons are combusted, there's always two products, water and carbon dioxide. Okay? Now, going through the process, right, of balancing this. Carbon, hydrogen, oxygen. Those are the three elements that show up in my equation. Taking an inventory to begin with. 1 carbon, 4 hydrogen, 2 oxygens in the reactants. Now, we didn't get to one like this on Friday, so this is the first time we'll go here. When we count up the products, we see that there's 1 carbon and 2 hydrogens, but when we are taking the atom inventory, we have to take account all of those types of atoms in the whole reactant side. So oxygen shows up in this product, but it also shows up in this product. We have to take the total when we're looking at it. So the total amount of oxygen on this side is what? 3. Okay? You got 1 here in the water, and then 2 here in the carbon dioxide. Okay? Now, my advice to you when balancing equations, if you end up with a situation like this, where you find one element showing up in 2 different formulas on the same side of an equation, like oxygen showing up here in carbon dioxide and water, both in the products. Start with elements that only appear in one formula on each side, because that's our only chance to change those. For instance, first, do we have to do anything with the carbon? Carbon's balanced, but hydrogen isn't. Let's not start with oxygen because oxygen shows up in a bunch of places. Let's start with hydrogen because we can only change CH4, we can only change methane in our reactants and water in the products because that's the only place hydrogen shows up. So, what are we going to have to do here to balance out the hydrogen? Right? Got to put the coefficient out in front of the water to double the amount of hydrogen. Now, that changes my hydrogen from 2 to 4, right? Everyone see that? But it also changes water. Or sorry, not water. It also changes oxygen. There are 2 oxygens here, but remember, we have to take the total. So now, by adding the coefficient out in front, how many total oxygens are there in the product? There are 4 total oxygens in the product. Okay? And then, right, now to fix that, right, we're going to have to put a 2 coefficient out in front of that oxygen, and that takes that from 2 to 4. Okay? Good there? Next, page 216, number, check sure. 27. Number 27. Read it. Determine what are your reactants and what are your products. Write a chemical equation. So page 216, number 27. Read it. What are the reactants? What are the products? So it tells us that there are two reactants to this reaction. What are the two reactants for this reaction based on the reading? What are the two reactants? Zinc, metal, and hydrochloric acid, right? Trey, you found zinc on the periodic table, right?
Yep.
What is the symbol for zinc?
Z.
Zn. Okay. Trey, is it diatomic?
Nope.
No. Then, in the problem, they told you what hydrochloric acid was, right? Hydrochloric acid is HCl. Okay. And it says those two react to produce two products, right? What are the two products of this reaction? Zinc chloride, which they gave you a formula for, right? ZnCl2, and hydrogen gas, right? What did we just learn about hydrogen? It's diatomic, right? So hydrogen comes like this. Okay? No, go ahead.
Do you not do it for like when they're reactants?
You do it if it's in the reactants. It's just in this case here, hydrogen is only diatomic if it's by itself, right? So in this one here, that in the reactants of this reaction, the hydrogen is joined together with the chlorine. That's why it's not H2Cl, right? It's only diatomic when it's by itself. Okay? Catherine, go ahead.
Does it really matter like what order you
No. If as long as you have the reactants separated from the products, it really doesn't matter. No. Yeah, so if you have these flipped, that's fine. Okay? Yeah, but I mean, it would be a problem if you had zinc chloride over here. Like that would be a problem. But
Yeah.
as long as the reactants are separate from the products, no, it really doesn't. Okay. All right, before we balance, what type of a reaction is this? This one's a little trickier.
It's a single replacement.
It's a single replacement reaction. Okay? Christine, how can you tell that it's a single replacement reaction?
Because the zinc was alone and the hydrogen was chlorine, but then they switched.
Good. That zinc was by itself, right? The hydrogen was joined together with chlorine in a compound, but then the zinc goes in and kicks out hydrogen and forms its own compound, right? We started with an element by itself and a compound, and we ended up with an element by itself and a compound, just different element and different compound. As far as balancing goes, zinc, hydrogen, chlorine, 1, 1, 1 in the reactants, 1, 2, 2 in the products. Right? So that's pretty easy. Coefficient here, that goes to 2 and 2. Okay? Good there? All right. For homework tonight, I gave you this sheet when you walked in. It says balancing chemical equations. If you go to the calendar, you will see that on Monday's date, oh, too far, your homework, balancing chemical equations problem set, and then there is a link that says problem set answers. If you click it, guess what you'll find?
The answers.
The answers, all right? Now, hold on, wait, one thing before you go. One thing that it doesn't specifically say to do, but you should, is make sure you can identify what type of reaction it is. Okay? I will have that written out on the answers so you can check out what type of reaction it is. Okay? Quiz tomorrow over balancing equations and identifying reaction types. Open notes.